Okay, this is the lecture video for MAC1140 pre-calculus. We're in section 12.5 where we're going to be taking a look at binomial expansion and some of the formulas that going into being able to do a binomial expansion. So we start off with one of those formulas called the combinations formula. When they make the notation n over j in parentheses like that, that indicates the combinations formula. This is the actual formula if you wanted to do it by hand, but of course you have a key on your calculator that will take care of all these calculations for you because there are several of them. You would first need to do this value factorial at the top. So if you remember from previous sections in this chapter, if you're doing like 3 factorial, that means 3 times 2 times 1, all the way until you get to 1, and you're doing a product of all those. And then you have to do another factorial here. You have to subtract these two values and do a factorial at that for that value. So again, you can shortcut all this work just by using what's called the combinations key, and I will demonstrate that on some subsequent problems. Just some shortcuts that you're going to notice as you start to press these into your calculator. You're going to notice that whenever it is a combination formula involving n as your top value and 0 as the bottom value, you're going to get a 1. And whether you do it longhand, you would see that you would get a 1, or whether you do it by your calculator, of course. When the values match, you're also going to get a 1. Okay, these are the two cases where you get the top value. When the bottom value is 1, whatever that top value was that you started with, you're going to get that as the overall value. Or when the bottom value is 1 less than the top, you're also going to get n. So that's up to you whether you want to memorize those or not. But again, you can press any of these into the calculator just by using this key. I also wanted to mention that these values can be taken also from what's called a Pascal's triangle. So I just wanted you to, imagine that the values for the combinations formula if they were to be arranged in a triangular display, and let's say you were doing 0 over 0, then 1 over 0, then 2 over, where all the values on the bottom were zeros. You would get a 1 all down this column, and then remember I also said that when the values match, that's equal to 1. So you would get all 1s coming down this side. These combination values transformed into their overall values is what you're seeing down here in Pascal's triangle. All 1s here because they all come from this. Here where they match, top and bottom, all 1s here. That's what you're seeing here. And if you're familiar with Pascal's triangle, then you remember that there is a symmetry that takes place on either side of the triangle. Like if you have all 1s coming down the left side, you have all 1s coming down the right side. If going down the second row in, if they all have a difference of +1, like if you add 1, add 1, add 1, then all of the second row coming in from this side all have a difference of 1. So there's a symmetrical quality to this Pascal's triangle, which makes it easy to use, but then you'd have to memorize all the values. And it's not that hard to memorize this, but that's up to you how you want to do it. You can grab these values, like for instance, if you were going to put this into your calculator, 0 over 0 using the combinations formula, you would get a 1, and you could go and grab it from there. If you were going to do 1 over this j value right here, 1 over 1, you would be getting a value of 1 also. So it's up to you if you want to use the Pascal's triangle to get these values, or you can use the NCR key. Okay, but I did want to just remind you of Pascal's triangle. Okay, this is just one of the rules that we went over in the theorem, that Whenever the bottom number is 0, that's going to be equal to 1. And you could, get your way out of this problem by just putting any number over 0, and you would see you get a 1. It wouldn't matter what you put up here. And then when the value at the top is n, but the bottom is 1, this was part of one of those theorems that I showed you on the previous page, that's equal to n. Using your calculator, once again, I want to demonstrate that this is the key that you're going to be using right here, the NCR key. You're going to put the n value in first, then you're going to go look for this key, then the combinations key, and then you're going to put the R value. So you're just going to be using the combinations key in the middle. Okay, so this represents the n value. And then this represents the R value from using this key like this. And you're going to press it in like this. So first thing you're going to do is press the 5 so that you're giving it this value first. Okay, so that's 5. Then you're going to go look for this combinations key, which is under math. And if you go over to the probability formulas, there you see it right there, where you're feeding in the n, feeding in the r, but using the combinations formula, which is what this is in the middle. So you can just select that. And then you're going to press in the other value that's down at the bottom, which I know they were calling it n and j. No, we're calling it n and r. And this, another way of saying this when you're talking about probability, is n items selected R at a time. And it just has here what to press. So the next thing that you would press is the 3. And then, so let's see, after this we did math. We went over to probability. And then we went down to the NCR key. Then we pressed in the 3. Okay, press in the 5. Then you're going to go grab this, then press in the 3. So this would be equal to 10. Okay, using the binomial theorem, I think this is much easier to explain and demonstrate than it is to try and understand this theorem. It's really not that hard, but we're going to be using it to expand binomials. That's why it's called the binomial theorem. See how there's 2 terms here, and you're raising it to the 6th power, which means you would have to, if you were going to do it by FOILing, you would have to go x plus 3 times x plus 3 times x plus 3 times x 6 times, and you would be sitting there all day. So this is shortcutting the way right to x plus 3 to a power of 6 using the binomial expansion theorem. Okay, so in the binomial expansion theorem, I'm going to demonstrate for you, and you'll see that, it's not that hard. Okay, so we're going to start off with 3p plus 3 raised to a power of 4. And in order to use these combinations formulas, which are really just values that represent the coefficients that are going to be in my binomial expansion. So I can tell you that one way for me to write this, and let's see, I don't know if they write it as easily as this, but I'm going to write it like this for you. This is really just this theorem right here. I'm just going to put a little bit more detail on it. You're going to start off with the n, whatever this value is right here. You're going to start off with that over 0 as your first coefficient. You're going to take this portion of the first term of the binomial, and you're going to also raise that to a power n, and these are going to decrease. That will be multiplied by the second term of the binomial, raised to a power of 0. So n on this first term, 0 on that second term, and these are going to increase, which you'll see what I mean as I continue. So then the next term would be, next coefficient, instead of n over 0, it would be n over 1. And remember I was saying that the first term, the power on the first term is going to increase, so the next time, the next power that you would see here is going to decrease on this first term, so it would be n minus 1. And then that second term, those powers are going to be increasing. So if it was 0 before, it's going to be 0 plus 1. All the way till you get to this term. Let's see if I can move this over. All the way until you get to the point where these two values match, and you've gotten to the point where the first term has gone down to a power of 0, and the second term has reached a power of n. All right, let me see if I can just squeeze this in a little bit better. I want you to be able to read it. I have enough room here. Try to write smaller. Okay, you're going to go all the way until these match. And your A term has gone to gone all the way down, because remember it keeps decreasing all the way down to a power 0, and your second term has reached all the way to a power of n. Okay, this is just that formula rewritten. Okay, so let's try that here. So we're going to start off with, I'm going to come down here. We're going to start off with n over 0. And so the power here, this is your n value right here. We're going to start off with 4 over 0. We'll let our calculator do that. That's going to be coefficient. And we're going to take the first term of this binomial, just like this says. We're going to start it off with a power n. This is the one that's going to be decreasing in its power. And then the second term of the binomial, which is a 3, it's going to start off with a power of 0. And it's going to be increasing. And you might want to put those two words on the power when you begin the problem, just so you can keep track on this. Is the first one is supposed to be going down, 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 and the second power is supposed to be going up, up, up. Let's go to the next term. Okay, next term. And this is just supposed to be, I don't know why I keep putting a line there. Be n over 1. Okay, fix that if you wrote it with what looked like a fraction bar. Okay, so the next one would be like this. So now it's going to be the n value over 1. We'll do a factorial there, and that'll be the next coefficient. And now this first term, which was 3p, that's going to be decreasing. So now we're down to a power of 3. And the second term of the binomial is going to be increasing. It was power 0. Now it's going to be power 1. Keep going. Okay, now we're going to go to we're going to go to the next coefficient, and instead of 4 over 1, it'll be 4 over 2. Remember, we're going to keep going until these values match, and that's when we know to stop. And then it's going to be for the first term and the second term of the binomial. This is the first term, and remember, on that first term, the powers are decreasing. 4, 3, 2. And on the second term of the binomial, which is just a plain old 3, those powers are increasing. So they were 0, then they were 1, now they're 2. Moving to the next term, almost there. So now it's 4, combination 4 over 3. Now use the first term and the second term of the binomial. Here's the first term. Here's the second term, and put those powers on it. For the first term of the binomial, it's going down. 4, 3, 2, 1. And for the second term of the binomial, it's going up. It's increasing. 0, 1, 2, 3. One more term. We know that this is the last term because you are to keep going until your combination numbers match. And then it's first term of the binomial, second term of the binomial. Okay, and these have the first term of the binomial, those powers were going down. They started with power 4, then 3, then 2, then 1, finally 0. So see how you're ending up right there? Where the first term finally makes it to 0 with its power, and the second term of the binomial finally reaches a power of n. And that's because it was going up. 0, 1, 2, 3, and 4. And now you're going to do some calculator work. And you're going to look at using the combinations formula if that's what you want to do. Remember I was saying anytime you have a 0 on the bottom or when they match, you're going to get a 1. So this is going to be 1. This is going to be 3 to the 4th power, p to the 4th power. If you don't know what that is, just go 3 raised up to the 4th, that's 81. So this is times 81 p to the 4th. Times 3 to the 0 is just 1. All of that's my first term. And if you want to keep, going on with that term, it's just 81 p to the 4th. Okay, moving on to the next term. 4 over 1, you could do the combinations formula if you want to, or you can also, try to memorize these theorems. If you have a value on top and a 1 on the bottom, it's going to be equal to 4. But you could also get that from your calculator. Okay, we had a 4 on the top and a 1 on the bottom, so that is going to be a 4. But just to demonstrate the combinations formula, you can use the NCR key. So you would put the n in first, just as I demonstrated in example 2, when you had a number at the top, number at the bottom, and how we pressed in this number first, then we went and grabbed the combinations formula, then we pressed in the bottom. That's exactly what you're doing here if you want to do it by calculator. You would press in 4, then grab the combinations formula, then press in 1. So just to demonstrate it, if you do want to do it that way, 4, math, over to combinations, over to this, go grab that, and then press the 1. And you get 4. So we already did that. Okay, then as far as this next term here, it would be 3 cubed. If you already know what that is, it is 27. Don't forget to cube the p as well. And then you're multiplying by 3 to the 1, which is 3. And then you can just continue working on that. 4 times 27 times 3. So 324. And this is your p cubed term. Okay, moving on to the next one. 4 over 2. If you want to press that in, it's going to be 4 math over to the probability formulas, which is where the combinations formula is. Grab that combinations formula and put in the bottom value. And you get 6. So it's 4 combination with 2. So for this part right here, we got a 6. Then from this part, we get 3 squared, which is 9. Don't forget to square the p. And then you're multiplying by 9 again. Okay, so this is 6 times 9 times 9, or 6 times 81, however you want to press it in, and that is 486. 46 p squared. So we have our first degree term, third degree term, second degree term. So we're doing this instead of foiling it out 6 times. Okay, so we did everything here. Increasing, that one was decreasing. Okay, so we're up to this term now. We can do 4 comma 3, and it's up to you if you want to have the formulas memorized where when the top value is one greater than the bottom value. That was one of the theorems that I gave you here, if you might notice. See, this is 1 greater than this. This is 1 less than that. That's saying the same thing. So you're going to get n. Again, that's at the top. So this would be 4, but go ahead and press it in if you want to. You can press those in. It would just be 4 over 3. It would be 4 math over the probability. Grab that, then do the 3, and you get a 4. Okay, so that was for that piece right there. 3p to the first power would be 3p. And then 3 to the third power would be 27. So you'd have 12 times 27. And that's 324. P. And then I'm going to point something out to you after we get done here. I want you to see the symmetry of the coefficients here, as well as what we saw in Pascal's triangle. Okay, so when they match here, you're going to get a 1. This would be 1, but put them in the calculator if you'd like. Anything to the 0 power is 1. And 3 to the 4th power, that is 9 times 9, 81. Okay, so 1 times 1 times 1 is 81. Okay, so what I wanted you to notice is that the symmetry around the middle term. This is the term right in the middle. There's 2 terms to the right, there's 2 terms to the left. Notice that the term directly to the right has a coefficient of 324, and so does the term directly to the left. Notice that the term 2 spaces away from the middle is an 81, the coefficient, and so is the coefficient 2 places to the left. So they have a symmetry on either side of the middle term, that is the coefficients. Okay, we have our 4th degree term, 3rd degree term, 2nd degree term, 1st degree term, and our constant, which is what we would have gotten if we would have foiled up to the 6th degree. Okay, so this is that binomial expanded. Okay, moving on to this problem, example 4. So we're going to use that same binomial expansion where we're going to start with a combination coefficient of n over 0. And we're going to separate the 2 terms of this binomial into a first term and a second term. And I will, just show you and remind you how one power decreases while the other power increases. So I'm going to start it right here with the n value over 0. Always start with 0 as your coefficient. And the n value over 0 as your coefficient. And then you're going to take the first term of the binomial, starting it at a power of n, and then the second term of the binomial, which is y to the 6, raising it to a power of 0. You might want to put these 2 notes on the power. This one is on the powers. This one's going to be going down, and this one's going to be going up. Maybe help you focus. Okay, so then the next term, next coefficient, instead of 4 over 0, it would be 4 over 1. And then it would be first term of the binomial second term of the binomial, and don't forget the power on the first term is decreasing, so now it's 3, whereas the power on the second term is increasing, so now it's 1. Next term, instead of 4 over 1, 4 over 2. Combination of 4 over 2. Again, we have our first term of the binomial, our second term of the binomial, and the first term is going down. We went 4, 3, we're at 2 right now. You got to be careful not to put the powers on the wrong thing. And then on this second term, we're building up. So this was power 1, now we're at power 2. So again, now we're at 4, 3. Combination 4, 3. We have the first term of the binomial, the second term of the binomial, and the powers on the first term are decreasing. So we're now at power 1 on that first term, while the powers on the second term are increasing. So we're here. Then on our last term, we know that this is the last one because we go until the end, this top value and the bottom value match, the n and the j values. So this would be 4, 4. And then let's see if I can squeeze this in. Hopefully I can. So it's x to the 7th, slowly going down to the 0. And we started at 4, 3, 2, 1, 0. Whereas the second term is building all the way up to the n value. Okay, now we can get our calculator to assist from here. Okay, the coefficient right here is 1. Whatever the top value is, if the bottom is a 0 in the combinations formula, you're going to get a 1. And then here we're going to have x to the 7th raised to a power of 4, which is x to the 28th. And then anything to a power of 0 is just 1. And you can continue with that if you want, working on that term. Might be easiest to do it like that, easiest to focus. Okay, then 4 over 1, that's just going to be 4. Whenever the bottom value is 1, it is equal to this top n value. So even if you put that in the calculator, you can do that if you want. And then x to the 7th raised to the 3rd is x to the 21st. And then y to the 6th raised to a power of 1 is y to the 6th. Okay, so this would be 4x to the 21st times y to the 6th. Then 4 over 2. I'm going to put that in. That would just be 4 math, go over 2. Combinations formula, then put the 2, and that's equal to 6. So this would be 6 times x to the 14th. When you raise a power to a power, remember you multiply those powers. And then this would be y to the 12th. So that would be 6x to the 14th, y to the 12th. Moving to the next term, 4 over 3. And again, there was this property here if you want to use it, that when the top number is 1 bigger than the bottom number, it will be equal to this top value. Okay, that's the case here. This is 1 bigger than this, so it's going to be equal to 4, but you can put that, you can put any of them in your calculator. This will be x to the 7th raised to a power of 1, or just x to the 7th, where this is 6 raised to a power of 3, so that's y to the 18th on your y's. Okay, when they matched, it also comes out to be 1. X to the 7th raised to a power of 0. Anything to the 0 power is just 1. And then this would be 6 raised to a power of 4, so that would be y to the 24th. Okay, bringing these terms down, I already did this one. This would be 4 x to the 7th, y to the 18th. And then this would just be y to the 24th. And we are Done. Okay, moving on to example 5. In example 5, use the binomial theorem to find the coefficient of x to the 7th in the expansion of x plus 1 to the 12th power. So let's do this until we get to find the coefficient of x to the 7th, until we get to that particular term. So here we go. Okay, we're starting off with the n value, which is this. That's your n value right there. So it's 12 as our first coefficient over 0. Then we take the first term of the binomial, raised up to a power of n, and then the second term of the binomial, raised up to a power of 0. Don't forget, this n value decreases, it goes down, and this one increases, it goes up. And you want to keep going until these two values match. Unless the problem allows you to stop, because if you're just looking for the coefficient of x to the 7th, then you're only going to have one term out of all of these products that we're creating that's going to have just x to the 7th in it. So if you can get to that before going all the way to the end of the problem, then you can stop. Okay, so let's see the next term. This is obviously not going to be the x to the 12th, the x to the 7th term. We're at x to the 12th here. So next term would be increasing to 12 over 1, going with the first term of the binomial, allowing it to decrease while allowing the 1 to increase in its power. Then going, and you don't have to expand them all because you're really just looking for that coefficient of x to the 7th. So then next coefficient would be 12 over 2. Going down on the exponent for this first term, so that now we're down to 10. And then the second term of the binomial, that power is going up. Next term, it was going to be 12 over 3. First term of the binomial is an x. Those powers are going down. We are now at exponent 9, whereas the 1 is going up and has a 3 on it. Then the next term, let's just come down here so we don't have to squash it in. Now we're at 12, 4 combination. The x is, the power on the x is decreasing. It was 9, now it's 8, whereas the 1 is going up. Going to the exponent that we actually need. Coefficient of that would be 12, 5. This would be going down from 8 to 7 on that first term, and then this 1 would be going up to a power of 5. So it would go on and on, except we've been asked about this specific term, x to the 7th. So we can do 12 over 5. We can go 12, 12, and go to math. Oops, missed it. 792 times x to the 7th times 1. 1 to any power is 1. So what is the coefficient of the 7th degree term? There it is right there, 792. Okay, moving on to the last problem. We're just learning, these combinations and how it relates to Pascal's triangle, just to do binomial expansion. You're raising it to a power, that rather than repeatedly, because it would just be a ton of work if you were going to FOIL it out to get the answer. So this takes the place of that. Okay, this one says to find the 4th term in the expansion. Okay. So it's not too bad. Okay, so we're going to start off with realizing that n is equal to 8. And we're going to start off with that n value over 0 as our first coefficient. Then we're going to take the first term, raised to a power of n. These will be decreasing. And then we're going to take the second term of the binomial, which is -2, and raising that to a power of 0, and those are going to be increasing. Okay, going on to the second term, where instead of 8 over 0, we're climbing up to 8 over 1 with our combinations formula. The x would be decreasing, the x term would be decreasing in its exponent to 7, whereas the -2 would be increasing in its exponent to 1. Then we move on to the third term, building up to 8 over 2 with our coefficient created from the combinations formula. The x term would be decreasing in its power, whereas the -2 would be increasing in its power. Moving on to the fourth term, which is what, let's just go like this. We need that. Okay, so then this would be 8 combinations 8 over 3 for the coefficient, and this would be the first term of the binomial that is going down in its power, whereas the -2, that power is going up. Okay, let's make sure we have all this right. 0, 1, 2, 3 on that back term, 8, 7, 6, 5, and this is the fourth term. Of course, we want to simplify it, so we need to get this value right here. Get that from the calculator, and we're going to multiply it by -8. Okay, so 8, hit the math key, go over to probability formulas and down to the combinations formula, and then feed in the bottom number. That is 56 for this number, multiplied by x to the 5th, multiplied by -8. -2 raised to a power of 3 is -8. Okay, so multiplying -8 times the 56 that we got from the combination formula is -448 x to the 5th. And I believe this one asked you for the entire fourth term, which would be all of this. Sometimes they just ask you for the coefficient. Sometimes they just ask you for the entire expansion, as the first couple of examples that I did. And that completes everything in section 2.5. Just nice to have a short section. Okay, so that's it for